Hi. Thank you, Dr. Sims, for taking the time to answer a few questions about algae. My first question I have for you is, can you give me some background on your research?
Sure. My training is in biological engineering, and I've been involved for about 22 years at Utah State University and working on bioremediation. The research has been bioremediation of contaminated waste and contaminated chemicals, and the research orientation has been to transform wastes, waste chemicals, and sites that have been impacted to make those sites usable by the public, usable for industry, usable for business. So it's transforming contaminated areas and changing waste chemicals into useful chemicals, and contaminated sites into sites that can be used for production, whether that's business or services or industry. Specifically involved in using biological engineering, which would be to use microorganisms and engineer systems where microorganisms are allowed to and encouraged and engineered to transform waste chemicals into innocuous chemicals or into chemicals that serve a purpose to society. So going from chemicals that are not useful to society to chemicals that are useful in society. And as a result of that, then I've been involved in the formation or starting of a sustainable waste to bioproducts engineering center at Utah State University in collaboration with the city of Logan, Utah municipality, so that we can actually bioremediate wastes and actually make them into useful products. And those could include biofuels and bioproducts.
All right, thank you. Second question I have for you is, can you explain the importance of bioremediation and wastewater treatment to the success of the algae industry?
I think that bioremediation of wastewater is going to be a critical component of the success of the algae industry, including algae biofuels for power, for transportation, liquid fuels, and also for other bioproducts. The integration of wastewater treatment, bioremediation with the algae biofuels industry really represents a fundamental game change strategy for both industries, both the wastewater treatment industry and the biofuels industry. The idea of using algae for biofuels and wastewater is not new. It was initiated in the 1960s in Berkeley, California. However, the implementation of that has not occurred, and it's time to do that. What we see is that there are advantages to both the biofuels, algae biofuels industry and the wastewater industry. From the algae biofuels and bioproducts, wastewater treatment offers basically free nutrients, nitrogen and phosphorus, which are critical to the algae mass production industry. Water comes free. The land for these wastewater treatment facilities provide land that's free in terms of the algae industry to look at mass production. The photosynthetically active radiation that comes down to help grow the algae is also provided for free. The infrastructure for wastewater treatment is already there, and there are over 7,000 ponds in the United States alone. And there are more than in the developing parts of the world that could utilize technologies for mass production of algae. So the algae biomass industry for production and harvesting has an infrastructure already set up in wastewater treatment plants all over the United States that could be taken advantage of. These wastewater treatment plants provide full-scale, unique opportunities to learn how to cultivate algae and learn how to harvest algae and the mass quantities of biomass that are going to be needed to make the algae industry successful. So while we are working in the laboratory in fundamental aspects of genetic engineering and microbial engineering and metabolic engineering, we could also at the same time learn from full-scale wastewater treatment plants that grow algae how to look at mass cultivation and mixed cultures and mass harvesting of mass amounts of algae that are actually going to be needed in order to make enough biofuel and bioproducts. Okay? So on the wastewater treatment side, biofuels industry offers advantages to wastewater remediation. Algae remediation of nutrients is the least expensive way to go. The actual generation of biopower, biofuels, bioproducts can offset cost of wastewater treatment. And a specific example is the production of biopower and biofuels can be used to power the fleet, a fleet of trucks and other engines, power that's needed at a municipal treatment plant. This can result in less expense to a community locally, less expense for taxes to actually operate a wastewater treatment facility. So the wastewater treatment plants benefit. Taxes can be reduced or changed to other useful kind of uses, and the biofuels industry benefits by having demonstration of this. So as a result of integrating the wastewater treatment industry with algae biofuels industries, you can have new businesses, you can have new services, you can have new technologies from waste to bioproducts that all come out of this collaboration. So what I think is this is an opportunity to integrate the two in a new way that's never been integrated before, to take advantage and cost savings to both industries, and to really help the biofuel, algae biofuels industry to really demonstrate that it can be successful large scale.
All right, well, thank you so much for your time.
Thank you, appreciate that.